All right, so we left off in R6. We kind of discussed, we finished talking about how to factor. Again, because we're not in factoring yet, and if you feel too uncomfortable with that, that's okay. You guys can just plug them in and then find which one gives you 0. And you will find that the ones that give you 0 is at x equal -3 and x equal 2. Okay. So let's continue to R6, which is evaluating square roots or perfect roots. So all of you are familiar with square roots. So the square root of a number, say 25 is 5, right? Because 5 times 5 is 25. So basically you're undoing an exponent when you're doing the square root or an odd root or an even root, whatever it might be. So let me put in my photo. So the first thing that we want to do is to make sure we define what is a root. So there's a principal square root. So a square root is only for squares only. So for example, the square root of 25 is 5. Because this is 5 times 5, so that square root would be 5. A radical is also named as a root like this. There's this principal square root where it's only positives. When they ask for the principal square root, they're only asking for the positive number. So on example 1, they're talking about evaluating the principal square root. So they only want the positive answer because -5 squared is 25, but 5 squared is also 25. They only want the 5. They only want the principal square root. So on letter A, what's the square root of 36? So if you punch that in your calculator, or we know that the square root of 36 is the same as 6 squared. So the square and the square root will cancel, and your answer will be 6, positive 6. 6 is the square root of 36. And they want the positive number only. Now, B, you have to be careful because it's the square root of 1 over 9. So that's the same as the square root of 1 over the square root of 9. The perfect square of the square root of 1 is 1. The square root of 9 is what? 3. And it's only the positives that I'm looking for. Because 1/3 squared gives me 1/9. Questions on B? Nick, did you have a question on B? Nick, did you have a question?
Yes.
What was your question?
I missed the explanation, so maybe like the whole thing.
So you said you're missing the open. So basically what I'm saying is we're dealing with square roots that involve numbers that are perfect squares. Like what? Like 1 squared is 1. Like 25, it's 5 squared. 2 squared is 4. All of these have roots. 1, 4, 9, 16, 25. Do you see the pattern? Nick?
Yes.
So then
Yes.
we are
Yes, I
already,
see.
so we're now in here, 36 is a perfect root because that's 6 squared. And we want the principal square root, so we only want the positive one. There's a negative and there's a positive. Because -6 squared is also 36. But I want the principal square root, which is the positive only. So we did that for letter B.
So
Ryan?
basically so you just did 3 because that's the root of 9. You just did 1 over 3. So I got that then.
Yep. So 3 times 3 is 9. That's a perfect root.
Okay, yeah, all right.
And 1 by 1, it's 1. So this one, 0.001. Well, how do I get to that number? So it's, if I take the square root of 0.01 on your calculator, go ahead and do that. What do you guys get? Do you guys have your calculator? So if I go,
No.
to my calculator. And I want to find, okay, well, what's the square root of 0.01? It's going to be 0.1, right? Because 0.1 squared is 0.01. So my answer is 0.1. That is my perfect root, 0.1. And it's a positive. Now, D, you notice how you see the square root and you see a square? They cancel each other out. They're inverses. If I take the square root of a 2, these mean the same thing. This has a 2 on the outside. You don't see it, and it's never going to be there. But it's there imaginally. So square root and the square, they cancel. So your answer is 2.3 without doing anything. So you square and square root, those are inverses. They cancel each other out. Questions on either A, B? Use your phone, Michael. Oh, on the calculator? Or what, Michael? I didn't see it. Oh, yeah, those for the ones that don't have a calculator. Okay. So let's scroll down. Let's look at evaluating radical expressions. So we already know that the square root of 36 is 6. So we're going to evaluate it as if we were doing order of operations. So the square root of 36 is 6, but there's a times -4. So that's going to be -24. Same thing for B, the square root of 9. So what number gives you 9 when it's a perfect root? We know that's 3 plus, what's the square root of 16? 4, right?
4.
Exactly. So 3 plus 4 is 7. Now C is different because they're both inside. So what's 9 plus 16? That's the square root of 25, but that's equal to 5. The next one is, now look at the order of operations. So see how I have a 64 minus a 4 times 7 times 1. So the square root says 64 minus, now I multiply 4 times 7 times 1. That's 28. So what's the square root of what? What are they asking me to do on the, what's 64 minus 28? 36. So what's the square root of 36? That's 6. Zakia, did we get that right? Yeah. Okay. So that's how we simplify and evaluate radical expressions. So we're gonna try these. Ariel, did you have a question?
Yeah, on A, is the reason we're not finding the square root of -4 is because it's not inside the radical?
Yeah, 4 is multiplied. That's on the outside. That one doesn't have a
okay.
root. Plus, we can't evaluate nothing inside a negative. So if there's a square root and there's a negative number, that's not allowed. It's not in the domain. We'll talk about that. So the 4 is on the outside. Does that answer your question, Ariel?
Yes.
Okay. So we're gonna do the quick checks down here on the bottom. So same thing. We have 5 times the square root of 9. The square root of 9 is 3. So 5 times 3 is 15, right? And then we're gonna add. So 36 and 64, what's that? That's 100. So that's the square root of 100. What is the answer of that? What two numbers, if I multiply them, it has to be the same to give me 100. And the answer is 10. Thank you, Emily. Thank you, Michael. And it's a 10. Now these separate, only the square root of 36 is, we've done that so many times, that's 6. Plus the square root of 64 is 8. So 6 plus 8 gives me 14. Like so. And then if we do 12, so we have to do what's inside first. So we have the square root of 25 minus, this is a 12, and then times a -2. So that's a negative 24. So Daryl, is Daryl in here? Yeah, Daryl. So Daryl, you know how you said the two negatives? This is where this
I'm in
becomes
here.
addition. So negative becomes a plus. So that gives me the square root of 49, which is 7. So 7 is the answer for number 12. Questions on radicals? How do you guys feel about that? So it's radicals in order of operation, so it's kind of come back. Questions on this one? You guys are good? Everybody?
Why is
Nick?
it called why is it called a radical?
Why is it called a radical? I have no clue. So it's a radical, it's also, it's a radical and the inside is called the radicand. It's just the words. There's no much explanation about why it's called radical. It's
Okay.
called a radical or a square root, but the roots will change. So this one is just a square root or a radical. This one is a cube root because it has a 3, and then there's a 5th root. We're gonna learn things like that, a 4th root, a 5th root. So right now we're starting slow with just square roots.
Got it.
Yeah. Let's look at the other one. Determine whether a radical is rational, irrational, or not a real number. So what is a rational? A rational, it's a positive or a negative number that is in fraction form. And irrational are all the square root of 2, the square root of 3, the square root of 5, the square root of 7, square root of 11, the square root of 13. All of these are irrational. When you have something like this, that's irrational and not a real number. Not a real number is when you have a negative inside the root. So whenever you have something negative, like -1, it doesn't even matter what it is. If there's a negative here, that's automatically not real. This is not real. It's called imaginary. We'll learn about those later. So rationals are the ones that we've seen. So like 15, the square root of 36, 2 radical 5, like those are okay. So the principal square roots and the perfect roots are rational. So that's what we've done. The square root of 20 is an irrational because it's not a perfect square. The principal square roots of a negative, see how there's a negative inside? That's not a real number. So these are examples that they're giving you to show you whether something is a rational, irrational, or not a real number. So what we're gonna do, so if a radical has not a perfect square, we're gonna be approximating it or we're gonna be simplifying. So that's what we're gonna be doing next. So writing a radical as a decimal. So this is an irrational number. But if I put it in the calculator, so if you put the square root of 5, it's going to be roughly 2.24. I'm rounding it. So on your homework, they might ask you to evaluate square roots that are not perfect. So then you just have to use your calculator or simplify. Any questions on number 3, example 3? We're good on example 3? Okay, so example 4. The square root of 51 is not perfect. How do I know whether something's perfect or not? Well, if we remember, well, 1 squared is 1, 2 squared is 4. Is 3 perfect? No, because no number, no real number will give me 3 as an answer. 3 squared is 9. 9, so 1 is a perfect square, 4, 9, 16, 25, 36. What's the next one? 7 times 7 is 49. And then the next one would be 64, and then the next one would be 81, and then the next one 100, so on and so forth. So the square root of 51 is not a perfect square, so it's irrational because it's a perfect square. So all we can do is use our calculator. So when we use our calculator and we round to 2 decimal places, that's 7.14. The square root of 169 is actually 13 because 13 squared is 169. If you did not know that, you can try your calculator and it will give you your answer. What about C? The square root of 81. Is this irrational, rational, or not real? John, what is this? What is C? C is not real because there is a negative inside the square root. Not real. Once there is a negative inside the root, we're done. So let's go over here. So this one's a copy of the other one. So let me scroll down. So let's look at this one. There's a true or false. True or false? Negative numbers do not have square roots that are real. That's false because negative numbers do have square roots. But not, so basically they're saying -5 squared is 25. Yeah, that's, a negative number does have a square root, but you cannot be a negative within the square root. So this is not allowed. Okay. So basically, the first one is saying you can get a number. So if I take the square root of 25, you can get 2 things. You can get 5 or -5. 5 is the principal root. -5 is another root. So it's 5 and -5. So let's look at number 7. So see how the 7 squared and the square root, these will cancel. And my answer will just be 7. This one, be careful because it's going to be a negative inside the root, but it's a square. So you're going to have to do the absolute value of -15, which is +15. You're going to say, oh, these cancel and this is a positive. Yeah, but because you're under a root, we have to do an absolute value. Same thing here. This X, we don't know if the X is positive or negative. So we have to say, okay, well, that's going to be the absolute value of X. The 2 and the square root will cancel. And your answer will be an X, the absolute value of X, because you cannot be negative inside a root. That's why with this one, we had to take the absolute value. So the absolute value of -15 is 15. And then D, what would be the answer for D? Well, you can see it, but we don't know the value of this X. So that's going to be the absolute value of 3x minus 1. So please don't forget that. So if I say this, the square root of 7x squared, the answer would be the absolute value of 7x. Because I don't know what X is. X can be negative, but that's why we're using that absolute value. Any questions on this one? So then D was the absolute value of 3x minus 1. So then we prevent not having something real, right? Because once we have a negative inside my parentheses, I'm no longer real. Questions on this one?
Yeah, I have a question. I mean,
Yep.
since we're finding the absolute value,
Uh-huh.
3x minus 1, or I thought that we couldn't have a negative or as an absolute value.
What
But
do you
over
mean?
here we have so over here it says 3x minus 1 isn't minus 1
No, but they're all
negative
together.
value?
So this is
Oh,
together.
okay.
This is all together because it's a 3x minus 1 in a parentheses. If this was like this, like that, and then a -1,
Okay.
so that's different. You wouldn't even be able to solve it like that because they're together. You can't, these wouldn't cancel.
Okay, makes
different
sense now.
So let's do the quick checks. What would be the answer for number 18? Be careful. It would be the, what would be the answer there, Nick?
The absolute value of A.
Yes, the absolute value of A. Excellent. What about for 10? Do we know 10? 10 is positive. So the square root and the square will cancel and we're good. The answer will just be 10. What about for 20? I like number 20. What would be 20? It would be the
Positive
absolute
14.
value of negative 14, which is 14. So be careful because you already have a negative. You have to take the absolute value. For 21, we don't know what Z is. So it has to be the absolute value. And then what about the last one? What's 22? What would be 22? The absolute value of 2x minus 3. Thank you, Michael. So Leo, did you understand how on number 18 we got the absolute value of A?
Yes, I understand now.
Perfect. So this one is going to be the absolute value of 2x plus 3. So let's scroll down. So that's how we evaluate a square root whenever you have a negative on the inside. Well, first of all, because you have a square, you're good, but you have to take the absolute value. Let's look at number 4. Use the product rule to simplify square roots. So we know that 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so forth. These are all perfect squares. However, a square root is simplified if the radical does not contain any factors that are perfect squares. For example, we have the square root of 18. The square root of 18 is not a perfect square, but 9 is. 9 is a factor of 18. So we can split it. So if we have the square root of 18, we can split this as the square root of 9 and the square root of 2. So this would be 3 root 2. Because we simplify. So we break down 18 to a product of something that does have a perfect square. And that's how you simplify a root. So if we look at, well, this one's simple because the square root does have, so 100 does have a perfect root, right? It breaks into the square root of 25 and the square root of 4. That's 5 times 4, which is 10, which we know that. Okay. So there is a product rule for square roots. If you're multiplying, so this is a rule. It's called the product rule for square roots. Write this down on your note. Because again, this will show up on your quiz and it will show up again on your homework. So the square root of A and the square root of B are non-negative reals. If you have, they're multiplying on the inside, you can split them. That's what the rule says. So I'm going to do 32. So 32 breaks down into 16 and 2. So that's the square root of 16 times the square root of 2. The square root of 16 is 4 times the square root of 2. And that's it. That's how you can simplify. 4 root 2 because 2 can no longer be broken down. Any questions on that? What if you wanted to do 8 and 4 instead of 16 and 2? Well, you need to be careful because you would have to do that method twice. Because 8 and 4, the 4 has a perfect root, but not 8. So then you have to break down 8 as 4 and 2. So it will make it complicated. So you always want to get it to the maximum root. So for example, question?
Yeah, so we're basically just factoring in a way.
Yeah, exactly. We're finding the
Okay.
factors and then simplifying it. That's it. So how we found 32, 16 times 2, we split them. The square root of 16, we know that's 4, and the square root of 2, it doesn't have anything, so we're done. So how do we find it? So we write the radicand. So the radicand means the inside of a root. Write the radicand as the product of factors of which is a perfect square. So you want to have a perfect square. Look, and this is key, look for the largest factor of the radicand that is the perfect square. So that's what I meant about the 8 and the 4. 8 times 4 does give you 32, but 8 doesn't have a largest perfect root. So that's where I'm trying to get at. Use the product of rules of squares to write the radicand as products, and then take the square root of the perfect square. So we're going to do that for A and B. So who is in the square root? 72. 72 is a product between what two numbers? So think about it. We want the greatest. So yes, we do have 8 and 9, but there's one more that's greater one, Michael.
36 and 2.
Yes, thank you, Nick. 36 and 2. So we're going to break down 72 as 36 times 2. So the -3 is for the ride. The -3 times the square root of 36 times the square root of 2. We are going to simplify the square root of 36 as -3 times 6 times the square root of 2. That's -18, the square root of 2. And that is the answer for letter A. Questions on letter A. So again, we break it down. So Michael, if you would have done 8 and 9, you would have to do it again with 3 and 3, and then 4 and 2, and then again. Do you see what I'm saying? So it's always the greatest one. Let's look at letter B. How would we do that? So for letter B, you need to be careful because letter B is the square root of 75x squared. This means the square root of 75 times the square root of x squared. I know that the square root of an x squared, this is the absolute value of x. Just to start off with, I know that. So I split these two and then I take care of the square root of 75. I need to simplify the square root of 75. Thank you, Michael. It's 25 and 3. This breaks down as the square root of 25 times the square root of 3. The square root of 25 is 5 root 3, and then there's an absolute value of x. So my answer is this. Five root 3, the square root of x. Do you see how I got the square root of x? Sorry, the absolute value of x, everyone? Questions on that one?
Do you leave the answer like that?
Yes. So on your homework, it's going to, so this is the solution, including the absolute value of x. So this is the number and this is the variable. Does that answer your question? So see how they have it? So all they did, they brought the absolute value into the front. They usually have the square roots at the end. That's what they typically do. So you want to stick to this. So who asked that question?
I
About-
did.
Oh, yeah, so they put the square root all the way at the end. That's all. But it's the same answer.
Okay, yeah.
Did I answer your question?
Yeah, I just wanted to verify, like, if, like when we do our homework or take quizzes, that it recognizes the answer we put in.
Oh, yeah, absolutely. So, if you want to stick with this, so you're more secure, then yes. But it shouldn't mark you wrong because it's the same answer, but just if you feel comfortable, just do it this way.
Okay, got it.
Yeah. So if A and B are non-negative Then what did we do? Well, we found the roots, right? That's the square root of A times the square root of B. To simplify 75, rewrite it as 25 times 3. So help me out with number 25. How do I break down 20? What's the perfect root? It's going to be what two numbers? 4 and 5 to the square root of 5. Because the only perfect square root that's closest, 10 doesn't have one. So the only factors of 20 are 1, 2, 4, 5, and 10, and 20. Right? So we get 2 root 5. Ariel,
So
did you
the-
have a question?
Yeah, so for number 25, the 4, that goes outside of the radical because that's the perfect square, or
Yeah,
is
so we,
there a reason for
yeah,
that?
well, so for 20, which one has a perfect square root in the factors of 20? So the factors are 20 are 1, 2, 10, 4, 5, and 20. So is 1 a perfect root? Yes, right? 1 squared is 1, but it's not the greatest. 2
Right.
doesn't have a square root. It's not perfect. 10 does not have a perfect root. 4 does. 4 does. 5 doesn't. And 20 doesn't. So the only one is 4. That's why the 4 is there.
Okay.
So you have to do everything, all the steps to identify which one is either the greatest or it's the only one you have. So for 72, we know that the greatest is 36 times 2, right? Because we could have said 12 times 6, but neither 12 nor 6 are perfect roots, but 36 is, and it's the highest. So 36, and then what about the x squared? So this is going to be the square root of 72 times the square root of x squared. This is what, Nick? What is this answer?
That is the absolute value of x.
Yes, thank you. That's the absolute value of x. Oh, sorry. Not YouTube kids. That's my daughter. Sorry. She's not here, but she plays with the tablet. So 72, sorry. 72 is the square root of 36 times the square root of 2. So that's 6, the square root of 2, and the absolute value of x. But as Nick mentioned, what if I have to write it this way? So let's keep it that way. As the book. So let's stay consistent with the book. So there's my final answer right there. Any questions on this one?
Actually, yeah, I have a question.
Yeah.
So if that is the way it's answered in the book, are we gonna take all our quizzes are and tests are on the computer, right? So there's not gonna be like a written test, right? Okay, so we'll have to recognize that is another answer. Okay, got it.
Yes, that's right. Because when you input an answer and the computer doesn't like the way you write it, it's going to mark it wrong. So that's why I want to clarify that. So just whatever I highlight, that's the notation that we're going to be using. The textbook. So then there's no mistakes, right? Does that answer your question there?
Yep, we're good to go.
Okay, awesome. So we're going to do that with the following. So let's simplify an expression involving a square root. So the only one that has a root is this one. But we already talked about this one. Simplifying the square root of 20 was 2 root 5. We already did that. So it's 4 minus 2 root 5 all over 2. But we learned a property that says 4 over 2 minus 2 root 5 over 2. So 4 over 2, that's a 2. And then a 2 and a 2 cancels and minus root 5. So, who told me about this one? I think it was you, Ariel. That it's like you cancel one and you cancel the bottom. Was that you?
Yeah.
Or was that John? I don't remember. Where, yeah, I think
Ah.
it was you, that you wanted to cancel, you can only cancel when you have a unique 2, right? So we split the 4 divided by 2 minus the 2 root 5 over 2. So you have a 2 on the top and 2 on the bottom, they cancel. 4 over 2 is 2. So that's gonna be my answer. Any questions on this one? So we're gonna do that, and then we're gonna move to R7. So let's look at 27. So for this one, I have to simplify the square root of 45. What has the perfect root for that? Who can tell me the multiples of that one? With the highest square root. 45 breaks down into what, 2? 15 and 3 doesn't work. What, John?
9 and 5.
9 and 5, thank you. So it's gonna be the square root of 9 times the square root of 5. So that's gonna be 3 root 5. So I'm gonna bring this to 6 plus 3 root 5 all over 3. And I'm gonna play that game again of separating them because they have a unique denominator. So it's gonna be 6 divided by 3 plus 3 root 5 over 3. 6 divides 3 2 times. 3 and 3 will cancel and I'm left with root 5. Any questions on number 27 before I go to 28? Okay, so let's look at 28. So for 32, what are the multiples of 32? Which is the highest? What are those numbers? With the greatest,
16 and 2.
thank you, Ariel, 16 and 2. So that breaks down as the square root of 16 times square root of 2. That's 4 root 2. So 4 root 2 will go into this. So we have negative 2 plus 4 root 2 over 4. And then I split them. So I'm going to split them because they have one unique denominator. So it's going to be negative 2 over 4 plus 4 root 2 over 4. So then here it'd be negative 1/2 because you divide the 2's, they did go in by 2's, and then the 4 and the 4 will cancel. So then this will be plus root 2. And that's going to be my answer because the 4's will cancel. The 4 on the top and the 4 on the bottom. Thank you, Michael. Yeah. So the 2 and the 16. Yep. Any questions on this one? That was R6. So we finished R6. So that was simplifying radicals. Simplifying radicals and evaluating radicals. For the next one is our basic geometry, R7. We do have 15 minutes of class remaining. Class does end at 9.